Welcome to The Explainer. Today, we're diving right into the nature of science. And honestly, we're going to completely flip how you think about facts, theories, and really the physical world around you. If you're the kind of person who loves getting to the absolute bottom of how things actually work, you are in the exact right place. We're looking at empirical grounding today. Basically, the ultimate reality check for any idea. Let's get right into it.
So here's a question for you to kick things off. What's actually stronger, a fact or a theory? Just take a quick second to think about how we use those words every single day. It's a super common misconception that theories are just, educated guesses that are patiently waiting to graduate into indisputable facts. We say things all the time like, that's just a theory, right? Kind of implying it lacks the ironclad certainty of a hard fact. But today, we're going to put that everyday assumption to the test against the actual reality of scientific methodology.
Because there's actually a massive divide between our daily vocabulary and the formal scientific framework. While non-scientists usually look at theories as vastly inferior to facts, the nature of science tells us a wildly different story about empirical data and physical reality. In the scientific world, the ultimate test of any idea isn't about how clever or mathematically elegant it sounds, it's purely about its agreement with physical reality. And in that framework, get this, observations are actually stronger than facts and facts are stronger than theories.
Section 1. The true empirical hierarchy.
Okay, let's break down the actual power dynamic in scientific knowledge to see who really holds the cards when we measure the natural world. Let's look at the true hierarchy of empirical grounding. Think of this as our roadmap. At level 1, at the very top, we have observations. Level 2, in the middle, we have facts. And at level 3, down at the bottom, we have theories. By looking at their roles and relative strengths side by side, we're going to see exactly why raw data absolutely reigns supreme over even our most complicated ideas. Let's break down each of these levels, starting right at the top.
First up, raw physical reality, the observation. We define this as direct sensory inputs or instrument measurements. So imagine you're standing in a lab looking at a dial, and you record the needle moved to 5.2. That specific observation literally cannot be altered by human interpretation. It is what it is, raw physical reality. And because it's completely untethered from our personal opinions or explanations, it acts as the strongest foundational anchor of all knowledge. It is the absolute bedrock, no debate.
Dropping down one level, right in the middle, we have facts. Now, facts are extremely reliable, confirmed observations that we generally accept as true. A classic example would be that water freezes at 0 degrees Celsius at sea level. But notice the relative strength level here. It's only middle. Why is that? Well, because a fact relies on repeated observations and standard measurement conditions. If vastly better measurement techniques come along tomorrow, a fact can actually be refined or updated. So while it's highly reliable, it's still entirely dependent on the observations that built it. Finally, down at the base, we find theories. These are your comprehensive explanatory models. Think of massive ideas like germ theory or plate tectonics. These are incredibly powerful systems of ideas that explain why the facts occur in the first place. But here's the major catch. They are at the absolute most vulnerable level of our hierarchy. No matter how much brilliant math backs it up or how universally accepted a theory is, it has to be modified or even completely thrown in the trash if a single verified observation contradicts it.
Section 2. The power of raw observation.
Let's really explore why a simple, straightforward observation holds so much more weight than a brilliant, comprehensive theory. This is where the actual mechanics of scientific truth start to get super fascinating. It's a concept called empirical primacy, and it basically means data always wins over explanation. Science is fundamentally empirical, right? A theory can beautifully explain thousands of past events, but if a single reproducible observation conflicts with that theory's predictions, the observation wins, hands down. It overrides the theory completely. Even Albert Einstein's mind-blowing theory of general relativity was considered provisional until the 1919 solar eclipse provided the exact astronomical observation they needed to confirm that gravity actually bends starlight. The raw data of the physical world just cannot be ignored, even if it completely ruins, or in Einstein's case, validates a perfectly good explanation.
So the crucial takeaway here is kind of the ultimate plot twist of science. It's perfectly captured in this idea. Facts and theories must bend to match observations, never the other way around. Think of it like the mighty Goliath of theory. It's huge, it's deeply impressive, it explains so much of our world, but it must always, always bow to a single, tiny David of an observation. If the data doesn't fit the model, well, it's the model that's broken, not the data.
Section 3. Why theories must bend. So how does this build our understanding of scientific frameworks? Like, why exactly are we so perfectly willing to toss out our absolute best explanations?
Well, it all comes down to the principles of falsifiability and tentativeness. Under the nature of science, all explanatory knowledge is tentative. Theories absolutely represent our highest level of human understanding. I mean, they are the ultimate goal of science, to explain the why of it all. But they are strictly provisional frameworks. They are always subject to revision. Contrast that with an observation. Once an observation is strictly validated, it remains a permanent piece of data in the permanent record of the natural world. The framework around it might completely shift, but that data point, that's forever.
Section 4. Distinct roles, not rungs.
Now let's clear up one of the biggest everyday language traps regarding how these elements actually interact. We've all seen this familiar progression taught in schools, right? Step 1, hypothesis. Step 2, theory. Step 3, law or fact. People almost universally and totally incorrectly assume certainty is a ladder. We kind of think a hypothesis grows up, gets enough evidence, becomes a strong theory, and then finally, one magical day, graduates into a law or a fact. But the nature of science tells us this ladder is complete fiction. These are not rungs of certainty that an idea climbs over time. Not at all.
They are entirely distinct categories. Think about it like this. Facts are the world's data. Theories are the structures that explain those facts. One does not simply become the other. Ranking observations above facts and facts above theories isn't about one graduating into the next over time. It simply reflects which element has the final ultimate authority when a contradiction pops up. The observation is the judge, the fact is the jury, and the theory, well, that's just the argument being presented.
As we wrap up this explainer, I want to leave you with one final, thought-provoking question to chew on. What long-held fact in your own life is just waiting for a new observation to completely shatter it? You know, the true beauty of the nature of science isn't that it gives us perfect, unchanging, rigid answers. It's that it gives us a highly structured, wonderfully self-correcting way to navigate and understand our incredibly complex world. Knowledge is delightfully tentative. So keep observing, keep questioning everything, and always remember that even your very strongest theories must bend to reality. Thanks so much for joining me to explore the empirical hierarchy.